How to repair a Birmingham Dribbler, Part 4. Cleaning and polishing the boiler and other parts. Fitting the boiler to the chassis was difficult. I had to remove the rear axle to do this, which at least proved the concept of using Loctite 603. Once it was all back together, I gave the engine a test run using compressed air. Here's the story so far. The driving wheels are quartered and fitted to the axle using Loctite 603 as I've just mentioned. This clip shows the buffer beam back in place along with the buffers. The buffers are not spring loaded, they're just dummies. So as not to mark the buffers, I tightened them into position using a pair of pliers wrapped in a thick cloth. Now the fun begins. It's time to fit the boiler. This looked like a simple job. The boiler sits on the frames. There's a long piece of threaded brass bar which sticks out of the boiler at the bottom at the front. You can see it quite clearly in this clip, and I'm fitting the front wheels. These are steerable because don't forget, although it does resemble one, it is not really a railway engine. It has serrated edges on the flanges. It's for running around the floor. And you can rotate the front axle to make it run in a circle. As I mentioned in the first episode, this is called a dribbler because as it runs around the floor, it drops oil and water on the floor. In fact, it dribbles. I'm showing the measurements just to prove that this is a 2.5-inch gauge engine, or gauge 3. I have a problem though. I cannot fit the boiler with the axle in place. Very shortly after fitting the driving wheels, I'm going to need to remove one. And this is why I mentioned in the previous episode not to get any Loctite 603 on the threads of the bolt. Had I have done that, it would not have come out quite so easily. Here I'm using a very small blowtorch to heat the end of the axle. This should destroy the bond of the Loctite 603. Why don't I just use the bolt to hold the wheel in position? Well, the answer is simple. I don't think it's strong enough. That's what caused the problem in the first place. Originally, these wheels were just held to the axle with a very small countersunk bolt at each end. These kept coming loose, and it was during a retightening of these short countersunk bolts that the axle broke. In this clip you can see why I had to remove the axle. This is a really strange design. A bolt goes through a bar which is bent so that it's strong, and then a fibre bush goes onto the bolt which in turn screws into the boiler. The pressure of the crossbar on the chassis holds the boiler in place. It's a terrible design. This part of the clip shows me screwing the bolt into the fibre bush, then I applied some more Loctite 542 and bolted the entire assembly in place underneath the boiler. You will notice that the boiler is looking somewhat shinier than it did. I used my polishing spindle in the main workshop to do this. I know originally that I said I wasn't going to polish it up, but it didn't look good with the original scabby varnish all over it. I haven't polished all of the parts though. Here I'm fitting the plugs in the front and rear of the boiler. I've fitted silicone grade O-rings to make sure that they don't leak. Here's the one at the rear of the boiler. This is just below the valve that controls the steam that goes to the cylinders. I've fitted a steam grade silicone O-ring to this one also. The original large O-ring around the safety valve is a little bit perished and I need to change this, but I don't actually have a silicone O-ring the right size. While on the subject of the safety valve, here are the components that make up the safety valve: the body, the bolt, a piece of brass tubing, the threaded top cap that holds everything in place, and a very hard O-ring. I fitted a normal O-ring, but I went back to the hard one. I think it's possibly going to be better. I don't know. I'll find out when my friend James comes to visit and we steam it. This next job is fitting the steam pipe, and I think I've done this in the wrong order. I have a sneaking feeling that I should have put this in before I fitted the boiler, but anyway. I coated it in Loctite 542, screwed it into position, and I think I can persuade this pipe to fit into the tap, and as you can see, it did. The tap is fitted into the boiler, and I tightened the lock nut to hold the steam pipe onto the footplate. The final job is to fit the handrail stanchions. These are quite nice things. They seem to be not really serving much purpose, but they look good. I'm using a pair of pliers, I know, and it's not a good idea, but I was very gentle with the pliers and didn't mark the stanchions. The good thing about this design is the hole in the boiler is quite large, so I can push a piece of silicone rubber tubing into the hole, which is connected to my compressor, and when I open the valve, the air pressure makes the tube expand and therefore holds it in place. That's the theory anyway. To test run the engine, I fitted the firebox, and this will sit on this piece of mahogany to lift the wheels clear of the bench. Here's a bit of slow motion. I think I may have misled one viewer with a statement I made in a previous video about this being self-starting. I always try to get things right, because if I don't, there's a wealth of people out there who try to correct me. This will self-start, but only with either very high pressure or a heavier flywheel. Even a single-cylinder Mammoth steam engine will self-start if the piston is in the right place and suddenly gets a lot of pressure behind it. Just to recap, these are single-acting, not double-acting pistons, so in theory it is not self-starting, and my thanks go to the viewer who took the time to point this out. This is a toy steam engine, and it doesn't need double-acting pistons, and it doesn't need valves, it doesn't need much at all. Just the two cylinders, one at each side, with a piston in it. These are oscillating cylinders because they oscillate and admit and exhaust the steam using this method. For what it is, this engine is quite powerful and runs very well. Have a look at this. Everything was going well until the pipe blew out of the boiler. I found a silicone O-ring that more or less fitted the safety valve, but it's the wrong type. It's not a steam grade one, it's very soft. So instead I fitted two thinner silicone O-rings, and these seem to be okay. I've no doubt that I will find out when I steam it. Here's a quick flashback to episode 1 when I first started the job. All I have to do now is put the engine on a shelf for another 40 years, and I should get some more spiderwebs. This clip shows what it was like when it came out of the ultrasonic cleaner. Now it looks like this. It's an improvement both mechanically and cosmetically. And that concludes this short series about rebuilding a Birmingham Dribbler. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.